Science Center. And we are very excited to have, as our guest on this Tuesday night lecture series, Tom Farrugia. He is a graduate student at the University of Alaska School of Fisheries and Ocean Sciences. And he is looking at the feasibility of designing a skate fishery around these really cool animals. So he's going to give us a bit of background about his project and about how this is going to work. And with that, I'll turn it over to Tom.
Great. Well, thank you all for coming out. I'm really excited to be here and share some of this information with you guys. I really like Cordova, and I've been spending way too much time up in Fairbanks, which I just learned tonight that you guys refer to as Square Banks. That's the only place I've lived in Alaska, so I don't know any better. But I do have ideas of moving down here because I really like it. So I'm really happy to be able to present what I've been doing with you guys. I'm about 2 years into my PhD program, so a little less than halfway through, and so I don't have final results or anything like that. But I just thought that for a first go around, what I do is just kind of tell you guys about skates in general and why I find them so exciting, and then go into the research that I have done and that I'm still trying to do and the reasons behind it. So, and then the other thing that I really like is equating some of these biological characteristics or aspects to everyday life items, which I think gives me a better understanding of how maybe they work and ways to think about it. So that's why I tried to think about what skates would make me think of, and I thought about vacuum cleaners, and hopefully you'll see that at the end they really do act a lot like vacuum cleaners of the oceans. So just give you a quick idea of what's coming up. I'll give you guys a quick background on skates, on the species we have, on the reproduction, feeding, and ecological importance. Then I'm going to go into the potential for skate fisheries, and then look into the research that me and some other people are doing here in Alaska on the skate species that we have. Little research has been done so far on these skates, and so a lot of this is kind of new stuff. And then at the end, I'll just point out some ideas of things you can do with skates if ever you guys are curious about going into and trying some of these cool animals. So let's start with a really basic question. What is a skate? Cheap abalone, cheap scallops sometimes on the East Coast, although I don't know anybody who does it here. But how would you guys describe a skate? Yeah, exactly. It's very much related to shark. And in fact, it's part of this big group of species called cartilaginous fishes. There are about 800 species of these worldwide, and they're all the animals, all the fish that have skeletons that aren't completely ossified, so that pretty much stop developing at the stage of cartilage and never fully ossified their bones. These include the sharks, the rays, like the manta rays, the stingrays, the skates, and then this other group of kind of less well-known fish called the chimeras, or ratfish. There's a couple of these species in the deeper areas off of our waters as well. And all of these animals have this cartilaginous skeleton. If you then go a little bit, focus in a little bit more, if you remove the chimeras or the ratfishes, you get into this subclass called elasmobranchs that includes the sharks, the skates, and the rays. There's about 750 of those species. And then if you look just at the order Rahiformes, that's only 400 species, and that's just the skates and the rays. And all the skates are in one family, Rahidae, which is about 270 species. It's the family of all these fish that has the most number of species. They're very, very diverse for this group. And they range in color and size and things like that. But basically, the way to think about it, just like you mentioned, it's a flat shark is really the best way. Their biology, their physiology, their anatomy, except for being flat, is very much like a shark. And sharks appeared about 400 million years ago in the evolutionary time scale. And it took a while, a couple hundred million years, for them to flatten out. And then the modern forms of skates that we see today appeared about 150 million years ago. Now, people ask a lot, what's the difference between a ray and a skate? And in fact, English is one of the few languages that actually distinguishes between skates and rays. A lot of other languages just say rays. And people do use them interchangeably, but it turns out there's a biological difference between them. All ray species are live-bearing, which means that they give birth directly to baby skates that are fully formed, that look just like a miniature version of the adults, that can swim, that can feed on their own, and they come right out of the mother just like that. Skates, on the other hand, all their species of skates are all egg-laying. Most of the development of the embryo happens within these egg cases outside of the mother. So very soon after fertilization, the mother creates this egg case and then drops the eggs off. Another difference, it's not quite as clear cut, but it is a notable difference, is that most of the rays are in warmer waters, tropical, subtropical, and then skates are in temperate, subtemperate, and then subpolar regions. There are no species, as far as we know, of skates or rays in the Arctic or the Antarctic and really, really cold waters. And the last thing is that rays, some of them in the family called stingrays, have this barb or stinger on the tail, just one barb or stinger that is used for defense. This is what killed Steve Irwin. This is the thing that really, really, really hurts if ever you're walking on the beach down south and you step on a ray. On the other hand, skates don't have that stinger on the tail. They have a whole bunch of these little thorns all across the top of their bodies, and that's what they use for defense. So, you know, they're both flat sharks. They both look similar, but there are some biological differences between the two, and we have no ray species up here in Alaska. Apparently, there's been some sightings of manta rays every once in a while, but normally we don't have them. We just have skates. So we have 14 species of skates. One of them in this genus, Embryo, it's the rough-shoulder skate that's found mostly out in the Aleutians. Then we have 11 species from this one other genus, Bathyraja, which is the one that has the most number of species. They differ in size and coloration, but sometimes they are hard to tell apart. And then the two that we have mostly down here in the Gulf of Alaska are in this one genus Raja, and it's the long-nosed skate and the big skate. And the size of these pictures are proportional to their actual sizes. So the two biggest skates are the two that we have down here, the big skate and the long-nosed skate, followed by the Alaska skate and the Aleutian skate. But these are more commonly found in the Bering Sea. And the three species that I'm going to talk about today are the two that are down here that the skate fishery is toying with developing. And then this one species of Alaska skate, because it is the one that we have the most information up on in the Bering Sea. So those are the ones I'm going to kind of be talking about. There's some really cool characteristics about working with sharks and skates and rays. And one of them is that they're really easy to distinguish between males and females. So all males have these two structures alongside their tails that are extensions of the pelvic fins called claspers, whereas females do not. So right off the bat, if you see a skate, you can tell right away if it's a male or a female. A lot of species of fish you can't do that with. These structures are used for internal fertilization. Seems pretty obvious. It's very analogous to other things that we know of. And the size and calcification, the hardness of the claspers can actually give you an indication of the maturity of these skates as well. So if you get a male skate, you know it's a male skate, and you can tell whether or not it's sexually mature right off the bat. There's really useful tools for researchers. These are used in internal fertilization, as I said, and so for males, you can kind of figure out based on the claspers. For females, you have to go inside the female and actually figure out their maturity. So here are 4 pictures of the 4 maturity stages of females. They have 2 ovaries, one on either side. This is a totally immature juvenile with no development whatsoever. This one's starting to develop its ovaries. In this one, the ovaries actually have eggs. You can see they look like egg yolks, like chicken egg yolks. And then in this one, you actually have 2 egg cases that have been formed. So this one's ready to lay down egg cases. All this maturity happens relatively late in life. For a fish, it takes about 10 years before they mature. That's fairly long. And so it's, you can't really deal with them the way you would deal with pollock or something that mature much more quickly. And then they have a long life after maturity, so they have a lot of chances to reproduce after they reach maturity. But they only put down 2 egg cases at a time, one on each side, one for each ovary, every time they lay their egg cases. So they have very low fecundity. Depending on how often it is, they can have only 2 offsprings per year or even less. The actual reproduction is kind of interesting because they have this internal fertilization. They do have to find a way to actually copulate, which is kind of funny to see sometimes because it can be kind of awkward. But the male essentially chases down the female and has to find a way to grab onto her, usually with his teeth, grab onto a side of her wing or some other part. Right here, he's trying to just keep her from getting away. They twist and turn until they can find a way to actually copulate. These 3 are rays, which is what we have pictures for. For skates, we don't have any pictures of them actually doing it. This is the closest I could find. And it looks a lot more passive than what the rays are doing. But this is probably either pre or post copulation. like I said, it could be pretty awkward. What we have a lot of video for, though, is in sharks, because people take a lot of more videos of sharks. And so you can see how awkward it is. The video is not super clear, but you have the male hanging onto the female. It's, you know, trying to twist her so much that he's keeping her from swimming, drives her down into the substrate there, and is trying to copulate with her. He's like driving her into the soil. It's actually gets kind of rough with sharks. Females are known to have much thicker skins than males because they get bitten all the time during copulation, and they're totally oblivious to things that are going on around them. You could have nuclear war around them, and they wouldn't really get out of this weird dance that they're doing. And so we don't have anything similar to this video for rays or skates, but you can imagine something kind of like that, but with flatter versions of these animals. So after fertilization, they produce these eggs. Like I said, there's one for each ovary that gets produced. They get produced in this structure called the oviduct that goes down into the uterus. The females essentially produce this structure around the eggs, and it's this protein collagen, or this collagen protein strands that are really, really tough. And if you ever see one, they're extremely leathery when you just take them out of the water. Tori Baker was nice enough to lend me one that she found recently. It's dried out, so it's not going to be that leathery, but you guys can come up and see it afterwards. This is one, and I also have this pamphlet by the Alaska Fisheries Science Center, which shows you all the different species and their egg cases. So afterwards, if you want to come up and try to see if you can figure out which species that's from, you guys are more than welcome to do that. But they become very, very tough, and then as long as they stay wet, they stay leathery and really hard to get into. Like I said, they produce about 2 cases at a time, and most species only have 1 embryo per egg case, 99% of the species worldwide, except for 2 species, one of which is in our waters, and those are the big skates, which can have 3 to 7 embryos in 1 egg case, which is very, very rare. And if you look at one of those egg cases, this is it right here, they look really different. They have this really big, these 2 big ridges, this big bump, a lot of space inside for cramming in multiple embryos. This one's about 24 centimeters long, about 10 inches or so long, so they get really, really quite big. And then the way they're kind of laid down is really nothing very ceremonious. They just kind of lay them down on the ground. This is a submersible video, and you can see every once in a while there's an egg case, there was an egg case, one there, one there. They're just kind of laid down. It doesn't seem with any rhyme or reason, just in a general area that seems to be good for development. There's another one there. There's a couple here and there. These 2 dots right here are about 10 centimeters apart, so that's about the length of this egg case. And these are long-nosed skate egg cases down in Monterey Bay. And you can actually identify, like I mentioned, the species based on the egg case. So if ever you guys come across egg cases, they're easier to identify when they're wet and not all dried out. But you can see the big skate one is very much different from all the other ones. But even these you can identify based on certain characteristics what the different species are. And you guys might know these as mermaid purses. Some sharks actually also produce egg cases that don't look quite like this, look a little bit different, but they'll wash up on the beach, and they're pretty neat to find. So what happens inside while they're developing? This is a very fortuitous picture that the Alaska Department of Fish and Game got, where they were able to catch multiple egg cases of big skates at different developmental times. So you can see at the beginning here, you're just seeing 3 yolks, essentially. You can't even see the embryo that's on top of them. And by this picture, you can start seeing those red things there. Those are the embryos stuck onto the egg yolk, essentially. They're a big nutrient packet that they're going to use the energy to develop. And then right here, you see them almost fully developed, and there's just a little bit of an egg yolk left. Most of the nutrients have been absorbed. And then finally here, the egg yolks are completely gone, and they're ready to come out of their egg case. Now, how long does this take? Well, it turns out that the time to develop is actually based on the water temperature and not so much on the species. So this is a regression that Jerry Hoff did. He's at the Alaska Fisheries Science Center, and he works a lot with the Alaska Skates up in the Bering Sea. And he found out that all these dots is a different species of skates, but they were all raised at different temperatures. So here's the temperature in degrees, and these are the days to hatching. And as you decrease the temperature, it takes longer and longer for the embryos to develop. So this is a big skate that was raised in California in waters of about 11 degrees Celsius, which is about 52 degrees Fahrenheit. This is the Alaskan skate that he was studying, which was in waters of about 4 degrees Celsius and took almost 4 years to develop. That is a huge amount of time for just this little egg case to be sitting on the bottom of the ocean. So many things can happen to it. It can get caught up in a trawl, it can get ripped up by other things. There's predatory snails that can actually bore into the egg case and suck out the egg yolk and therefore deprive the embryo of its nutrients and kill it, essentially. But 4 years for it to develop. I don't know of exact water temperatures, but I think annual averages around here, maybe in the Gulf, maybe not in the Sound, is about 7 degrees C, about 45 degrees Fahrenheit. And so that gives you about 580 days for skates around here to develop. So about a year and a half for them to develop in this area. Does anybody know the annual water temperature for Prince William Sound is at the bottom, off the top of their head? I couldn't really find a good number that I felt was correct, but I think it's a little bit colder in the Sound, and so it might even be longer times. So what do they look like when they're in there? Well, if you actually shine a light through these egg cases, you can actually see them. And so here's a video of one beating its little tail and its little wings. It's really interesting because they're stuck in this permeable envelope that cannot exchange gas with the surrounding waters. So the water they have in there is all they have to breathe at the beginning. And what happens after a while is they'll actually create a little hole in the egg case that will allow circulation, and the skate inside will beat its tail or its wings to force circulation with the outside water to continue oxygenating the water inside the egg case. It's really pretty cool. If you find one of these and it's alive, one thing you can try to do, you got to be careful with it, is actually cut a window open in the egg case and then put saran wrap or some kind of plexiglass, really, really thin plexiglass, and glue it. And you can actually have a window inside the egg case. And this is a big skate egg case. You'll see there's 2 or 3 embryos in there. And so you can see them just kind of slowly moving. You know, if they have still plenty of space, or they might not need to circulate the water yet. You see this one here still tied to its yolk sac down there. These haven't been developing for that long. The egg yolks are still pretty big. And there's 3 or 4 of them piled in there. And as they develop, they'll take up more and more of that room. And after a time, it'll actually burst out. So what happens at that point is a slit will form usually towards one of the ends of the egg case, and the skate will wriggle itself out, and essentially once it's out, it is a fully formed skate. You can see how it's really, really kind of crammed in there, and finally it gets to stretch out its wings for the first time. And you know, at this point it's fully formed. It can eat on its own, it could swim on its own. It's still really small, and it's very vulnerable. Its thorns aren't hardened yet, so it's very vulnerable to being predated on by almost anything. So if we look at kind of the general life cycle that happens in these skates, this is from this species, the Alaskan skate, up in the Bering Sea. This is again a work by Jerry Hoff, and he found a whole bunch of these areas where there was a really dense aggregations of these egg cases along the canyons between the shelf and the slope in the Bering Sea. And so these are probably nursery areas where every year females come in, they lay down a whole bunch of eggs, those stay there for 3 to 4 years, and then some of the neonates, when they come out, they'll swim to the slope, some will swim to the shelf, and that's where they'll eat up and mature over 10 years or so. And then as adults, they'll mate, and then the females will come back to these areas and breed again. And we were able to figure this out in the Bering Sea because we found a bunch of areas with these high aggregations of egg cases that we're calling nursery areas. And we haven't found the equivalent yet in the Gulf of Alaska. Okay, so that's kind of the life cycle. Let's talk now about what happens, how they actually get to grow that big. They have big mouths. That's how they grow that big. They have big mouths. I have a couple of jaws here that you guys are welcome to look at when after the lecture if you want. This one was about a 80-pound, 90-pound big skate. So they get much bigger than that. This one here is from a 6 foot 1 inch big skate, and you can see that the jaws are really quite big on that. And what they use these for is sucking in water. As they're going along the bottom, they quickly open their jaws, and that creates a vacuum that sucks up prey. And then they have their teeth that holds on to that prey. Their teeth, if you look right here at the rows of teeth, they're almost like regular shark teeth, except the tip of them are laid down. So they have this really flat base, and then this little spear that comes up, but the spear, instead of pointing up, points towards the back of the mouth. And so this is dual purpose. The flat base of it allows it to crush crabs, scallops, clams, whatever. And then the tips that are pointing backwards allow it to hold on to any fish that it might grab in its jaws and keep it from wriggling out, back out. So they're pretty cool little teeth. They're made of the exact same thing that shark teeth are made of. And just like shark teeth, if ever you could find some, they would preserve, unlike the rest of the skeleton. But you'll see here, they're very, very small, and they're most likely won't be found once they've fallen off the jaws. And so what are the things that they eat? Pretty much anything that's on the bottom. And so that includes any kind of bottom-dwelling fish like sculpins or flatfish. I found a lot of arrow-tooth flounders in their stomachs. And then crabs, obviously, small crabs, big crabs, a bunch of cod, pollock, shrimp on the bottom. What do you guys think this is? What is it? Sandfish, possibly. It looked to me like a mackerel when it first came out of my mouth, of the stomach. So where do you guys think it got a mackerel from? It's kind of weird. Okay, what about this? I found one of these guys. What do you think is sticking out of its mouth? Yeah, it's a 2 foot long silver salmon. So who thinks that a skate can catch a 2 foot long silver salmon or a mackerel? Yeah, they can't. So what they're doing is they're essentially catching anything that's fallen off the lines that are being used as bait, or that are coming off. This one's probably in the gill net and fell off the gill net, and then it was just sitting on the bottom dead. And then the first thing I found, it was this skate, and it just gobbled it up. I mean, look at this. It's if you look at it goes all the way to the back. It's its whole digestive tract is this one salmon. It's pretty crazy. So they really go along and just suck up whatever's on the bottom. You guys are seeing a pattern here, maybe. That's what they do. So let's look at a little bit of a video of them doing this. Seeing this flat thing just moving around the bottom. Here they go. They're just kind of lazily going about, looking for stuff. When they find something, they'll cover it up. In this case, it's all dead, so they don't actually need to chase it. But they'll suck it up in its mouth, and then when it kind of lifts up, you can see it handling the fish, rotating it so it's head first going down the gullet. So here they are, just moseying along at the bottom, this flat thing, sucking up whatever they can find. And I started thinking, man, what does that make me think of? This kind of just flat thing sucking things up. And I thought of a Roomba, which, if you're not lazy enough to know what a Roomba is, it's an automatic vacuum cleaner. It just goes around your house and automatically sweeps up whatever's there while you're out of the house. And really, that's exactly what skates do. So they're going around, they avoid things just like the Roomba does, and they find stuff to eat. The Roomba uses, apparently, this is their promotional video, multiple sensors and dozens of behaviors to know where to go and what to sweep up, just like skates. Skates have electrical senses, olfactory senses. They can see, they can feel vibrations in the water. They use all those senses to find prey and avoid other fish, just like this guy's doing right here. And you'll see another one coming in and taking this fish right here. The Roomba has a bunch of great features. All right, it has wall following technology. All right, this skate has rock following technology. You can go right up along rocks and use its wing to kind of feel along the rocks until it finds something. The Roomba detects dirt with its dirt detecting technology. Rays have a fish detecting technology or a prey detecting technology. Right on its wings right there, you can see it felt that, it smelled that fish right there, and it was able to rotate over it and suck it up. When there's a whole lot of them, man, they just go crazy. And they start sucking up. All these little things are going to be sucked up. And look at this guy braking. Look at that. Did you see that brake that it was doing just in the middle of the water? The Roomba has a quick cleaning mode where it goes around when it finds a really dirty area and goes straight, spins, and eats. This guy, straight, spin, eat. Same thing. figures it out, sees it, whoop, spins, picks it up. Whoop, spin, picks it up. And finally, when it's had its fill and it's all full, the Roomba goes back to its home-based charging station. It's actually pretty cool. Same thing for skates. They get full, they stop somewhere, and they just rest for as long as it takes them to digest or to regain energy if they've been swimming for a long time. It's really crazy when I started looking into how similar these two things are. Now, obviously, the Roomba isn't self-thinking. It doesn't have behaviors where it wants to do something just like a skate does, but it really uses very similar probably behaviors and algorithms to figure out where it's going to go next. So I'm calling this the Roomba of the oceans, these skates. The Roombas, if you put a light on them in a dark room and then kind of follow them around, you'll see all these paths that it's done. Sometimes it stays in one spot. Sometimes it takes these long paths from one place to another. Sometimes it just kind of rotates over one area. Probably exactly what skates do. They'll find patches of food, stay there until they eat it up, and then go and find somewhere else to go. Now, this is kind of silly, and it's just kind of a way of thinking about the skates, kind of to get an image of them in the mind's eye, but they actually hold a fairly important ecological role. By vacuuming up all this prey, all this either dead matter or anything that's kind of in abundance on the bottom, by being non-discriminate like that, they do fill a really big role. As well as being an important predator, it's actually an important prey for a lot of seals, sea lions, marine mammals. The small skates are probably food for halibut or for peacock and things like that that also eat on the bottom. And they're also important competitors of things like arrow-tooth flounders, halibut, and probably peacock as well. If you zoom into this figure, this is an output of an ecopath model, which what it does is it analyzes all these organisms simultaneously and figures out where they are in the trophic level, and based on stomach analyses and things like that, figures out who's eating who. And in this case, they're doing it for the big skates. So big skates are at a trophic level between 4 and 4.5, which is fairly high. It's a little bit lower than Pacific halibut. And then just for reference, algae and things like that, primary producers, those are at trophic level 1. And then anything that eats trophic level 1 is at trophic level 2, etc. So all the things in green here are things that big skates are known to eat, and the bigger they are, the more important that is in their diet. So they eat a lot of bivalves. Okay, anything that's kind of sedentary on the bottom is very easy to eat, and they can crush them with those teeth. But they also eat a lot of capelin, pollock that are when they're on the bottom, arrow-tooth obviously when they're on the bottom. Big skates, large skates will probably eat small halibut at some points, shrimps, and things like that. On the opposite side, it's a big prey for stellar sea lions, sperm whales, and beaked whales. But also, if you look at here, what they've put into this model is a lot of the fisheries. And you can tell here which fisheries are the ones that are most influential in catching skates and are most responsible for essentially mortality in skates. And those are the rockfish trawls, flatfish trawls, sablefish longline, cod trawls. Behind here there's also cod longlines, and then halibut longlines. So those are the fisheries that are catching skates most often. So if we think a little bit of the skates and kind of step back from Alaska, skates aren't a really big deal in the U.S., but they're a pretty big deal on the global market. They, on the east coast of the United States, they've been fishing them for over 150 years. And this picture here is from Massachusetts, I believe, in the early 1900s, where they already had, a fishery for them essentially, and most of these would be coming or going to Europe, mostly France and Spain and a little bit in the UK. And currently, if you go to any kind of Asian market, you have a whole lot of skates. In Korea, I'm told that there's stores dedicated only to skate products. They have them whole, they have them winged, they have them frozen, dried, they have them dried and then powdered for medicinal purposes. And so skates are a big deal in Asia. And in Europe, they're a pretty big seafood staple. This is from a frozen aisle in a French market, a French supermarket. And these packs here are already skinned and winged skate wings. And in the back here, you can't see it, but it says from the provenance, or it comes from the northwest Atlantic, so essentially off the coast of Canada and the US. But what's really interesting is right next to that packet is a packet of Alaska pollock. So they are bringing in product from Alaska as well as from the east coast of the U.S., but currently they're mostly bringing skate wings only from the east coast of the U.S. And as demand increases in Europe or the populations of the Atlantic skates starts going down, we may see more and more of a demand on Alaska skates. And just to give you guys an idea, in 2008, about 65 million pounds of Alaska skates, or of skates from the East Coast went to Europe for a revenue of about $11 million. So, you know, it's nothing compared to pollock or anything like that, but it is, you know, a little bit of a revenue for those fisheries there. And every once in a while you see them creeping up. This is at the Pike's Place Market in Seattle. You have skinned skate wings for $4.99 from Alaska. There was a fishery, I'm sure most of you remember, directed fishery for skates. It was an experimental fishery here in the Sound in 2009, 2010. This was done at the request of you guys, really, that wanted more opportunities to fish skates, and so they tried it out. And mostly this request came from the fact that prices were pretty good for skates, 45 cents a pound. They still are. And when you compare that to pollock, for example, which I'm told is about 30 cents this year or something, or 25 to 30 cents, that's pretty good. You know, it's definitely nothing like a halibut, but it's not negligible, and it can be a big source of revenue if a lot of volume was able to be taken. Yep. So these right here was in 2009, 2010 for big skates and long nose skates, the guideline harvest levels. So that's essentially the quota that ADFNG puts versus the harvest. And so there was two districts, and what happened in 2009 is they didn't put a trip limit on boats, and so because they're relatively easy to catch, boats would come back in one load with the whole quota. And that was nobody's fault. You know, they didn't put trip limits, and so people went out there and caught whatever they could, which was quite a bit. And then in 2010, they put in trip limits, and you can see that they didn't pass the guideline harvest levels, but you had a lot less participation as well from the fishery. So fishermen found it much less profitable to go out and catch them if they can only bring so many pounds in one trip. And then after 2010, they decided not to have it keep going. There was several reasons for this, but one of which was there's a lack of knowledge in skates and relatively high catch rates. They're fairly easy to catch, so that kind of makes management nervous when you have those two things together. So currently you can only land them as bycatch. You're allowed to bring in 20% of your catch as bycatch, and a lot of times, especially in the Pacific cod longline fishery, most of that 20% is going to be skates because it's one of the more the highest priced bycatch they can have. And you catch them in any kind of long line, as well as the flatfish trawl fleet that's going out of Kodiak. And this lack of knowledge that's kind of making management hesitant to have a fishery for them is fairly recognized. So the Department of Commerce and Community Economic Development says that detailed biological information needed to enact effective management practices is lacking for most skate species. And then the North Pacific Fisheries Management Council says that to refine stock assessments for which little information is available, especially skates, is one of their priorities. So people know that we need this. We need more info before we can really establish a skate fishery. And so that's a lot of what I'm trying to do. I'm trying to provide that information and with the idea of, if it's possible, let's do it. There are a couple issues that we have to kind of answer in order to have this be possible. Main one is, can it be done sustainably? And the most basic question is, how many skates are out there? And people will tell you a lot, and I believe them. The problem is we need an actual, a fairly confident number on that to know how much we can harvest. And then also, if we have a number, is that all one big population, or are they little pockets of populations? That's gonna change how we manage them if it's one or the other. And if we start fishing them, are there any critical habitats that we should not allow fishing in that might be nursery areas or areas where there's big aggregations at certain times of year? On the flip side of, is it sustainable, is, can it be profitable? All right, are we going to have a fishery that has so many regulations in it that no one's going to want to participate in? Because that's not going to help anybody either. So a lot of that has to do with what kind of management system do we put in place, And then will there be a continued demand for skates in the future? Right now it's a pretty high demand, but is that going to go on? And especially from skates from Alaska, is that going to continue on? And then a really sticky subject that unfortunately I don't know if I'm going to be able to get at directly in my research is what do you do about the fear of increased halibut bycatch during a directed skate fishery? And that may be that you can take that into account on the kind of management system that you would employ. So there might be ways of doing it that way, but that is a very sticky subject for a halibut bycatch that's already pretty big in a lot of other fisheries. How do you deal with that in a skate fishery? So my research goal is to determine if the feasibility of a skate fishery in the Gulf of Alaska using an interdisciplinary study. This interdisciplinary study is going to look at a couple different aspects. First of all, the movement patterns of skates and also how the populations are divided up. So examine the movements in and among Prince William Sound, Cook Inlet, the general Gulf of Alaska, Kodiak Island, where there seems to be a lot. Okay, all those skates part of the same population or not. And then understand temperature and depth use in all those areas. Then develop a stock assessment, which is pretty boring, but it's really, really important. And it'll help us describe the patterns of abundance, as well as develop a model to know what's going to happen in the future if we take a certain amount of skates this year. How is that going to affect the populations 2 and 3 years down the road? And then finally, I'm going to try to answer this profitability question by integrating economic data. So describing markets for skates from Alaska and then determining the most viable harvest strategy for a skate fishery. So that's kind of what I'm hoping to produce by the end of my PhD. So it takes on a lot of different things, but hopefully it'll all come kind of together in one useful product at the end. So the movement patterns, the information that I get from this part of my project is going to feed into the stock assessment. It's going to tell us what kind of stock assessment we should build. And then from the stock assessment, that's going to be a really important input into my bioeconomic model. All right, so let's talk real quick about some of the things that I've been doing. The main one that I've been working on so far has been a tagging study. So answering the question, how much connectivity is there between management units? And then what are the depth and temperature uses of skates? And so I've done this so far by using both satellite tags and spaghetti tags. And then I'm going to start using acoustic tags this summer as well. So I used these satellite tags that are called pop-up satellite archival tags. And I put 5 or 7 of them out on skates in 2011 in Prince William Sound off the Department of Fish and Game survey. And here's the first skate that I tagged, which is actually the first skate in the world ever tagged with a satellite tag. So this is history in the making right here. But you can see the tag when it's just sitting on the skate, goes straight up. It's slightly positively buoyant, and it does that so it doesn't bother the skate by lying against it. Then we put the skate back at 200 kilometers when it works well. So it's just to know whether or not it's gone, you know, across the sound or out of the sound into towards Kodiak. That's what the kind of level of detail that it'll give you. It also sends back depth and temperature data at, you know, kind of summarized that isn't super fine scale either. But if ever you can recover the tag, then you can download the really fine scale data of depth and temperature up to like 5 seconds resolution. So then you have a really good record. And I was lucky enough that a fisherman, I think out of Seward, called Quinn Topher, I believe, sent me or found one of these in Port Gravina and sent it back to me. So for one of these, I was able to get the full record, and I'll show you guys that in a second. So here's the results. We got data back from 5 tags. 2 of the tags got lost. It happens. You're kind of sending this out blindly sometimes. You don't know exactly what's going to happen to it. But these are the 5 locations in Prince William Sound where I deployed them. I was on 1 male and 4 females between 110 and 165 centimeters. And then the red symbols here are where they popped up. So 3 of them were popped up really close to where I tagged them. 1 crossed the sound in about 90 days. And then another one popped off outside of Prince William Sound. So then the question is, can we go back in time between this time when I released them and this time when they popped out and figure out what it did? And for these 4 nothing much happened. It was hard to discern. It looked like they didn't really leave the sound. This one that came out of the sound has a really interesting story. Now, the one thing about this technology to get the location from the tag is it's really poor scale, and because they were on the bottom the whole time, they don't get a whole lot of light. And so the latitude estimate is actually quite poor. So I'm not even going to show you guys the latitude estimate. But the longitude estimate wasn't too bad. And the good thing is that our management boundaries here are pretty much organized east to west in the Gulf. And so just looking at longitude can tell you quite a bit. So here's what's called a longitudinal plot for one of the tags. This is the male skates. On here I have degrees longitude. So it was released at this longitude here in the sound. And then you'll see the track kind of progress from July 2011 to July 2012. So this is what it did. It meandered west until about 161 degrees longitude and then meandered back towards Prince William Sound. If you put on those boundaries, those longitudinal boundaries of the management units that are being used, in yellow here is Prince William Sound. So those are the east and west borders of Prince William Sound. And then you have the Eastern Gulf of Alaska Management Unit, the Central Gulf of Alaska, and the Western Gulf of Alaska. So this skate left the management unit of Prince William Sound, went into the Central Gulf of Alaska, went into the Western Gulf of Alaska, and then came back in the Central Gulf, maybe even back in Prince William Sound before it came back out again. So that is a pretty impressive track for an animal that, you know, up until now we thought was just sitting on the bottom most of its life. If we look at a map of what this looks like, so here's Prince William Sound. It went, at a minimum, it traveled to this point here, this longitude. That's as close as that's the minimum distance that it traveled without going through land, although it does kind of crawl over Kodiak there. And then it went back this way. And that's a minimum distance of 1,000 nautical miles round trip in about 11 months. So I thought that was pretty amazing. I was not ready at all for this level of movement from this animal. And then let's look at vertical movement. So this is a different skate. This is one that stayed inside Prince William Sound the whole time. And what you're going to see here is the depth in meters. But so 100 meters, about 50 fathoms. About 100 fathoms, about 150 fathoms. And you'll see here the line is the depth record. This is the one that I was able to recover the tag for. And it's going to go across. Keep your eye on about 130 meters and about 30 meters. And you'll see these are areas that it comes back to over and over again. But in between that, it makes these huge vertical movements up and down like crazy. Then it gets back to about 130 meters, but still with these big spikes. Then it starts going really deep, past 300 meters, almost to 200 fathoms, and then back to 130 meters. And at times when it doesn't move much, back down, and then back in May and June, it starts going shallow again up to 30 meters. Again, much more vertical movement than I was expecting. And what's really cool is, look at this area right here. Where do you think that is? Yeah? So what are these variations that we're seeing? Yeah, those are the tides. It's so still that you can actually detect the tides acting on the tag as the water is going up and down. So this is when it's back on its recharge base, like the Roomba. This is when it's not moving. That's what it's doing. Again, much more movement than we thought. These vertical movements, because Prince William Sound has got such a crazy bathymetry with lots of these deep areas and then shallow areas pretty close, it's probably still on the bottom the whole time. And all this vertical movement is actually horizontal movement across here. So if we look at all the species, all the individuals that we got, it spent most of the time between 0 and 100 meters, but some individuals spent up to 50% of their time between 100 and 200 meters, and then some even over 200 meters of water, 11% of their time. And then 3 skates remained in Prince William Sound the whole time. 1 moved to the Central Gulf of Alaska, and 1 moved across 3 management areas. Again, much more active than previously thought, and again, very much like a Roomba that's very active if you just look at it moving around. So I'm going to do more satellite tagging studies, hopefully, if I get funding. I need returns from the spaghetti tags. So if you see any, or if you know of anybody that's caught some, please let me know, or Department of Fish and Game, I'm doing that with them. And this year I'm also going to try to put out acoustic tags to be picked up by the array here in the Sound. So this is my reward poster. You'll get a cool hat if you send me the tag. And then a couple of other things. We actually found, or ADFNG found, possibly a nursery area just like in the Bering Sea for big skates. Here right off of Kayak Island, where they brought up a whole bunch of egg cases. I need to look at this. This is potentially an area that can give us a lot of information about their early life history. It could be one of these critical habitats for skates over here. You know, it'll tell us things like developmental time, sex ratios, size at birth. It can give us fecundity estimates and things like that. So that's something that I'm going to be working on this summer. The stock assessment, I'm not going to go into too much because it's a lot of numbers and a lot of computer work. It's not super exciting, but it's very critical. But right now we're getting our abundance estimates only from summer abundance surveys, and that's just not adequate. And so we're going to try to develop a stock assessment with the Alaska Fisheries Science Center that's going to use survey, observer, and landing data to produce essentially abundance estimates. And this, again, is a critical tool for management. And then finally, I'm going to be looking at the bioeconomics. So I'm going to get an idea of the global skate market data, which is the demand, and how much Alaska skates can be sold to that demand. And then on the other hand, I have the supply on with my stock assessment. This is how much fishers can harvest. So then the question is this profitable, given how much can be sold and how much fishermen can harvest? And that's when the bioeconomic model is going to answer that question based on the price of skates, the cost of fishing skates, and the harvest strategy that's in place. And then finally, what I'm doing here when I collect skates from Trident, I'm going to go to Kodiak and start doing nutritional content analysis on the lipids and proteins of muscles, livers, and cartilage. And potentially, there could be new products if more revenue is needed from the skate fishery. These livers are going to be full of omega-3 fatty acids. Shark livers are already used in supplements and pet food. It can definitely be used as well from skates. And then I found out that they have really, really big cheeks. A lot of meat on the cheeks, just like halibut, even bigger than halibut. And so, it's not as expensive as halibut cheek meat, but this can definitely be used as another kind of market product. Skate cheeks, just like halibut cheeks, are a little bit different than just halibut meat. And then the last thing that we really need to figure out is there going to be a mercury content problem? A lot of sharks are high in mercury. Is it the same thing for the skates here? And is that something that needs to be taken into account when people are consuming skates? So I promised you guys some skate recipes. If you haven't really cooked skates yet, they're to have a firm white flesh, just like halibuts. The biggest thing is do not overcook it. Because they're already kind of firm, it becomes rubbery when you cook it for too long. So that's the one thing that you don't want to do. But you can make some really good stuff. I mean, this looks amazing. It's skate with brown butter. You can Google it and get recipes. People have been eating skates, for a long time in the UK, so a lot of recipes come from there. They also make really good fish and chips, I'm told. I've never had it that way. And like I said, it's a stable seafood in Europe. A lot of things have been developed. Only trick is the preparation on removing the skin and the cartilage. So here's a quick little video of somebody from the UK explaining how to do it, if the sound works.
Hi, I'm Duncan Lucas from Passionate About Fish, and today we're going to show you how to prepare skate wings. Today we're going to work on a blend rate, understanding
same idea.
Several different species of ray that can be sold as skate. We're going to skin it by hand and start on the white side. We're going to start at this side of the fillet. I'm going to lift the skin with my finger in a cloth and then work my thumb around the very bottom edge of the wing and seam the skin naturally along.
He just kind of rips it off of the wing, which is pretty crazy.
Away from the skin, long movements down the whole length, and then I roll the skin back towards the knuckle, over the knuckle, and then again seam it towards the thicker side of the wing.
So he keeps doing that for a while, flips it over, keeps doing it still in the same piece of skin.
Very easily. Just keep rolling your hand covered. And I'm getting towards the very edge of the wing.
So anyway, so he goes on and kind of explains
the wing is now totally
once he's winged them, he takes off the trim on the side there. And then I just want to show you guys.
The easiest way to do this is to we're going to actually show you how to remove the two fillets.
So this is how he removes the cartilage, or removes the fillets from the cartilage, which is in the middle of the two fillets.
Then lie the blade on its side, and follow it
So
along the cartilage.
there's a cartilage,
Very
a
carefully
ray of
with the tip of
cartilage
your
right
blade.
there that's going this
See
way.
the blade working down
And just
the
by sliding his
cartilage.
knife on top of
I'm
it,
going to
he
remove
removes that
the first
from the
fillet
top of
very
the
carefully.
cartilage.
It gets very thin down towards the edge of the wing, so just run your knife down.
And then he does the same thing on the other side.
And fillet the meat away
And
from
then
the cartilage.
This
The
other
tip of
one, he
blade
does the
just
same
remains
thing at the
down
beginning,
wing, either side, and then I stop
but doesn't
short
go all the
and
way.
Don't release the cartilage from the wing. And I'm going to turn the wing over, do the same operation on the second side, cut down onto the cartilage, start the filleting, working the blade along the cartilage. Being careful because it's not a firm bone, it's soft cartilage, so just be careful that the tip of the blade doesn't go right through the cartilage. So we've got an envelope in the centre.
And he actually makes an
I'm
envelope
now
that
going
can
to
be
take the
stuffed.
scissors. I'm going to go
Takes the
inside
scissors
the
and
wing
takes out the
and just
cartilage
lift away
in the middle.
that
And then it's
cartilage,
got a little
the tip
pouch
of the blade,
that can be stuffed and then
working
baked.
around the
And
inside
that's
of
really,
the
really
wing
good.
very carefully in a nice curved shape.
So there you go. So again, you can Google this or
And that
YouTube
gives you
this
a
and
packet
get
that
this
can be
video.
stuffed or
But people have developed how to eat these in the UK because they've done
There
it
we
for so
have.
long. So anyway, I want to thank these people, my committee members, Bill Bailey and Bill Gilbert at the processors here that have helped me get skates, and then Westward Seafoods in Kodiak as well as ADF&G, the Science Center, CDFU, the National Marine Fisheries Service, and then I've been getting my funding from UAF and NSF to do this work. So I show you guys lots of skate fish, so now I was just showing you some skates just to change it up a little bit. So if anybody has any questions, I'd be happy. If you guys want to come up and check out this egg case and these jaws, please feel free. There's some pamphlets here if you guys want to know more. I can move this thing out of the way. Or if anybody has any questions.